G'day and welcome back to the channel, everyone. So, I had to think about things from the last video, and I don't want to create too much work for myself. So what I've done is I've put the pot back on where the resistor was, because as I said, I don't know that I need the 8 milliamps or whatever that's going through here at the moment. I'd rather run 6. That was my goal. So the only way to work this out, I'm not even truly going to get my answer without putting a load on it. But to be honest, because it's a triple Darlington, there is that much gain in the output stage that I reckon as long as I do get the swing in terms of voltage at the output, I think I'll be all right when it's loaded. And if I get over, then it should definitely be all right. I really just want to see basically where we're at. I feel like 8 milliamps is still a little bit too close to 10 and it's killing the gain of this transistor too much. This one, both. I mean, you do have the two of them, but one's only doing one side, so you need to consider the gain of each individually. And I do get that it's got the beta enhanced transistor. It's in the Darlington config, so it's going to have more gain, but again, I can't remember what that measured at. I did put it on the tester and put like a milliamp through it or something like that, I think, to see what the gain was, and it's all right. Anyway, what I want to do is power it up. Might have to reset the BIOS quickly. Let's just double check that. Yeah, no BIOS. Something's not right. Hold on. What on earth? Don't tell me we've still got issues. Hold on. Okay, nothing's getting hot. Hold on. What? Oh, God. Ha 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 ha. Poor amp. I was biasing the shit out of it. That'll do. That for testing purposes, that'll do. Even if it went down to 3.5, it'll be alright. If it goes up to 5.5, it'll be alright. That's fine. And it's stable, so I'll just leave that there for testing purposes. So now, let's go to AC. Let's look at the output. Ground. This is going to be fun. Alright. Yep, that's reading. Okay, I'm going to go get a signal. I'm going to hook the scope up also so I can see when it starts to clip and collapse or whatever you want to call it. And I'm going to feed a signal into it and see how much swing we get out before things start to get ugly. Let me just find the ground point to clip onto. God. Just reach that. Alright, okay. The ground point. Scope's hooked up to the output. Let me just turn the sensitivity down quite a bit. Start at 10 volts of division. Alright, I'm going to bring my signal generator over here. I'm going to try and hook it up. Alright. Already amplifying noise, that's good. There's bug input filtering on this, so that is totally expected. And there's a lot of switching noise and crap getting through this, so I've just hit the power button and the noise has gone down. So like I said, it's just a lot of that's common mode stuff and switching supply stuff. Anyway, 4 millivolts peak to peak, 1 kilohertz sine wave. I'm going to turn the output on. Alright, nothing bad has happened. I'm going to scroll down to amplitude and I'm just going to start dialing it up slowly. Now, just keeping my eye on the power supply and the scope. So far, there's nothing bad happening. This is actually wonderful. The waveform looks perfect. Let me just scroll across the digits so I can turn it up a little bit faster. Okay, now we're getting somewhere. Looks like the amplifier is working. I'm at 50 volts of division. Oops, wrong way. Alright, okay, going funny there. We've got negative problems just past there. What do we got? 37 volts AC. I'll tell you now, that is more than 250 watts into 4 ohms. So that's great. And the power supply is still taking the idle current of 71 milliamps, which means that we don't have cross distortion problems and stuff like that. As I've remember before, when it was unstable, I was saying that that shouldn't be happening. The current was going up as I was turning the signal up. All right, that's great. Now, let me give you guys a look at what's going on the negative portion of the wave clipping. So we get that. Let's do some experimenting. We can get up to 36.48 volts. We're going to look at that clipping thing in a moment. I'm just going to turn off my signal and power down the amp. Now, what I want to do, I do want to have a look at the Baker clamp still, but if I add that, it's going to have a lot of resistance in series with it so that it doesn't swamp out the work the transistors are doing too much. That'll really help with the Miller effect from the diode's capacitance too, to snub that out. Anyway, because I ain't just putting a diode across that, that's not happening. What I want to do now, this is running 8 milliamps. I've got, looks like 180 ohm resistor in there. I'm going to go get I think it was a 270. Let me unhook all this stuff, because it's going to get melted, get being in the way. Yeah, I'll just move everything back off to the side. It's probably going to be quicker. What I'll do is just do that, and then I can spin this around and I can get that resistor out. Let's get something larger in there. Say 270R. Alright. Alright. Yeah, that's 180 ohms. I'm just going to go get a 270 ohm resistor. I think that's going to leave it at about 6 milliamps. Maybe 6.5, something like that. That is where I wanted it to be. Let's see if we still get up to the same 37, 38 volts of gain. If we get more, if we get less, because that'll give us a really good idea of what the current's doing to the gain of the VAS. Alright, I've got a 270 ohm resistor here. Could already be tinned, I'm not sure, but definitely is now. So I'll just tack this in here. All right. Let's measure the current source current. I'll just turn the bias down all the way because, wait, I've just decreased the current. I don't need to worry about bias. The bias is going to be smaller, not bigger. Yeah, okay, that's all good. Let me just power the amp up to verify it's all good. Yeah, it's all good. It's got like literally no bias, as I thought. Okay, so yeah, we have fixed it. That's good. It's stable. All right, how many milliamps have I got now? 5. I wouldn't be surprised if that's a little bit over 5, but you know, I'm quite happy with that value. Let's stick a signal in it. Well, actually, first things first, let's bias it, because our signal's going to look pretty darn ugly if I don't bias it. Good enough, Australia. All right. Suppose you guys are going to want to see what's coming out the amplifier, aren't you? Just as much as me. I'll bring everything back over. Okay, that's all that. We have bias, we have signal, we have scope. I'm turning my signal back on, but first I'm just going to turn the input down quite a lot. By the way, there was a problem I just noticed. The input was at 3.8 volts, which is way too high. Okay, so this is missing gain. We have to investigate that. Anyway, let's continue what we're looking into for now. I'll just remember that number and do this test relative to that number, obviously. So I'm going to turn it on. And I can tell you now the current on my power supply went up a little bit already. But turning the signal up more is not making that increase a ridiculous amount. Alright, that's as high as I can go, and I'm sticking 4 volts into it now. However, we do have a little bit more gain on the VAS stage. That's closer to 39 volts now. Okay. Quite interesting. Now, I'm turning this down to 2 volts. We've only got 19.65 volts on the output. That is a major problem because that is about what? I don't know. Like, not full power. Half power or something. I'm missing gain. And it doesn't seem to be because of the VAS. I'm a little confused there. I wanted to get a feel of these resistors and transistors whilst they were swinging. As I said, I did calculate the resistors with swing in mind, and it seems I've done a darn good job because everything's cool. Don't know what to say. Missing a crap ton of gain. Alright, well, first things first. I'm going to turn my power supplies off, turn my signal source off. Originally, I had a 330 ohm resistor in there and I was only running 4 milliamps. Let's go back to that. Because it seems like we've just got more gain with less current. Now, obviously, there's going to be a point where it's going to drop off because if the VAS is starved for current too much, it will get dragged down by the pre-driver stage that's loading it, you know? But I've got a funny feeling that we're heading in the right direction here. I wouldn't go lower than 4 milliamps. I think that's quite good. So that was originally what my original design was. I've actually, this is hilarious. I've actually got all the 330 ohm resistors here. Oh goodness. If this ends up being what's going back in, I'm going to laugh so much. 330 gold, 330 gold, 330 gold, 330 gold. They're all 330s, yep, okay. Alright, I'm going to put a 330 back in it. It's going to be interesting putting one of these in it. Oh goodness. I could go get one with a longer leg on it, but I got a funny feeling that this is going to end up going back in it. The heatsink's going to come out and all that crap. So I'd rather just put one in and not... Oh, God. This is near impossible. Got one end in. Got the other end in. I'm sorry if you guys didn't get to see that on camera. That was extremely difficult to get to. I'm not going to bother reflowing and all that sort of jazz right now because I've got a funny feeling that these riser boards are going to come back out. The original transistors with the twisted legs going to go back in, blah, blah, blah. I'll retouch it all up when I do that, you know, obviously. The joys of amplifier building. I mean, I can't complain. We're getting somewhere now. Let's set the bias now. I already know that's 4 milliamps because that was my original thing. It's about, I think it was 4 milliamps. Let's test that first. What the hell am I doing? Yeah, it's 4.5 milliamps. Okay, beautiful. That's what's running through the input stage as well. Set the bias. That'll do. Take you guys back to the output. Is there really that much offset on the output now? What? Hey, where did that come from? What on earth? 6 millivolts? What? How the hell? What the bloody hell? How did that happen? I can worry about offset later. As long as it's not a problem. I just don't. Let's run a signal through it. Maybe I've turned the current down too much and the VAS is actually doesn't have enough current and it's having trouble controlling the output stage in a steady manner, stable manner. We'll know in a sec. Alright, I'm going to turn my signal on and we'll see what we can go up to this time. So that's where we were at before. Yeah, that goes higher now. You can go up to there, 39.5. That's a current, that's what I originally wanted. I'm going to leave that. I'm going to leave that. Now, we still need to investigate why we're missing so much goddamn gain. I'm pumping 4.1 volts peak to peak in there. If I dial this down to 2, which is already maximum input voltage you'd see. Yeah. That figure hasn't changed. That doesn't seem to be the VAS. So maybe I did my math wrong on the resistor values for the gain. I probably did, honestly. That's probably just me. Alright. We have a stable amplifier. We don't have a crap ton of bias anymore. What I'm going to do now, because I'm happy with what I've got at the moment, I'm going to, before going any further with this, because I've got all these things lying around everywhere ready to make up other riser boards and stuff like that, and these are coming back out, as we can tell. So what I'm going to do is I'm going to revert these back to just standing up on the board. I've still got the transistors off to the side, obviously, because I just put them back in the box. What? Oh, they could be buried because I've ordered more, so I may have dumped some new ones on top of. Wait, where the hell are they going? Ah, I did. I dumped new ones on top of them. So there you go. Like I said, when I realised how good these were, I bought some, and then I realised they were even better than what I thought they were, and I bought some more. So yeah, okay, that's what happened there. Alright, that was slightly concerning for a sec. So I'll revert everything back. So I'll put the 330 ohm resistor back in the other side. I'll get rid of these two riser towers and put that back how it was. Original transistors, 330 ohm resistors. I'll have a quick look at the other board. I'll put everything away that I don't need, and then we'll continue working because it's getting too cluttered here, and I've made some modifications I haven't made to the other board yet that need to get reverted back to how they originally were. So I'll get all that sorted out now, and then we'll continue working on the gain and the ugly negative clipping and all that sort of stuff. Alright, my apologies, small correction. Input stage is running at about 3.74 milliamps, something like that, maybe 3.5 milliamps. Sorry, it's a 470 ohm resistor for the current source for the input stage, 330 for the VAS. Just thought I'd put that correction out there. Sorry about that. Alright, so that is the original transistors back in. The riser boards are removed. I've also put the 330 ohm resistor in here for that current source. I haven't changed the two capacitors on this side for the 220s. If the circuit board looks a little bit gunky at the moment, it's because I just shot some PCB cleaner all over it, because there was flux piles and solder balls and crap everywhere. It still needs a proper clean down afterwards, but this is just so I don't get resistance between connections and solder balls shorting stuff and whatnot. So anyway, the other side's not hooked up at the moment anyway, so I'll sort those two capacitors out later on. Right now, what I'm interested in working out is, now we've got our 5.5 milliamps, 3.5 milliamps, I think it is, something like that, whatever it is. Let's now work out why I don't have enough gain. Actually, something else I wanted to have a look at. You know how it goes and clips on the negative portion, and it's got like, I mean, it's not oscillating, but you can see it almost breaks into something and it snaps straight out of it on that negative clip. Well, I want to see what the Baker clamp does to that. And if it helps that, I want to add a lot of resistance in series with it, like, 100 ohms plus. What I'm thinking of actually doing, to be quite honest, I've had to think about this. A much easier way of doing what I wanted to do, instead of making like separate current sinks and sources, would be to just make one current source for the beta enhanced transistor and run this entire rail off of a regulated sub-rail. So that's what I'm thinking so far, but before we get ahead of ourselves, there's other things to take consideration too. Like I said, I still got to solve the gain problem. The other thing is, I still plan on doing things to this. I might add remote references. I might not. I might not add external current references. I might not. The thing is, if I couple the LEDs to the transistor, it gives me the benefit of it being thermally coupled, thermally compensated. If I add an external reference, that transistor itself won't be compensated. Well, depending on how complicated I make the reference, right? So I might not add external references. I might, who knows, might add a sub-rail, may not. I'd definitely be more inclined to do stuff like that than add a Baker clamp, I can tell you that. Anyway, sorry guys, I'm starting to fall asleep. It's quite late. It is 3:30. I should have already been in bed by now. What should I do now? I think let's I'm gonna go get some sleep and come back and do the rest of this tomorrow. My brain's not working anymore. See you guys tomorrow. Alright, it's the next day and I'm not falling asleep now. So, first things first. I want to quickly have a look at what I was saying before, because it makes no sense to just keep jumping around doing different things and confuse you guys, even though it might make sense to me. So, we'll have a quick look and see if the Baker clamp has any effect on that negative clipping. Just purely for the fun of it, right? I would imagine bringing the negative rail down lower so the VAS transistor can pull down lower on the negative going side would fix that negative early clipping more than the Baker clamp, but let's still have a look. Also, the offset might have something to do with it. That's something else I want to have a look at. I'm not sure, when I noticed that it had like 5 or 6 millivolts of offset, if that was actually offset or if I still had this across the emitter resistor. So we'll have a look at all that now. First thing I'll do is I'll go across the emitter resistor and turn it on, just to make sure that the bias is where it should be. I think it is. I don't think I've touched it, but better to be safe than sorry. Powered on. Yes, okay. BIOS is all good. Wow, that's actually wonderful. I'm really glad. Finally. Took long enough to get there. Alright, that'll come up to like 5.5 and stabilize out. And then we can watch it to verify. Why not? It might actually overshoot by quite a bit because it's completely cold now, so the heatsink will have to start to warm a little bit. Yeah, it will. It'll have to start to warm a little bit. Also, I don't know if that pot has been knocked or not. I'll just keep my eye on this for a minute or so. It's not going to take longer than a minute for the diodes to start tracking. Let's make sure nothing's hot. No, nothing's hot. So we're running. I get the feeling that pot might be a little bit, because it was quite fiddly. I'm just going to leave it for now. I'll just be a little bit more patient. It is a diode string. It does have the thermal resistance of the heatsink there. You know, like you got your junction to case of the transistor, the case through the sil pad and heatsink, and then through the heatsink to the diode's case to junction. There's a bit going on there for the temperature to have to get through before the diode's actually going to track, and it looks like it is slowing down. And I'm happy with that, to overshoot by about 50% before it starts to slow down. If anything, that's just going to help it warm up quicker instead of having to slow, you know. That is definitely slowing down. I think the pot is just set a bit too high, because yeah, that's trying to stabilize now. And yes, the heatsink is starting to lose its coldness. So okay, the pot was just a bit high. That started tracking. It's just set a tad too high. Just want to see how it goes in the opposite direction. Now I've turned it down. I just want to see that as the heatsink drops off suddenly in temperature, the diodes, you know, are maintaining. It is, yeah. It's not still slowly going down. So that's wonderful. I'm more than impressed. Excelente. Alright, let's have a look at offset. Yeah, right. So there is offset. Interesting. I wonder where that's come from, because I certainly had no offset before, and I have had this thing biased before, so I'm curious. Maybe I'm running, you know, a milliamp or two, not enough current to the VAS transistor now. Before we have a look at this Baker clamp diode quickly, look, I'm a very thorough person. This is an audiophile amp I'm building here. You know, I'm going to be thorough on everything. So, I want to delve into this first very quickly. So, I know if I put my finger on this left transistor, obviously it's going to go the other way, but that's neither here nor there. I'm not sure if it's resistor offset, transistor matching, although they match really well. I've got a feeling it's something else, so I just want to have a quick look at that. What I'll do is I'll grab a couple of these mini clips and clean the board. Dumbass Dave now with the gunks on the bottom of it. That's alright. I've got plenty of cleaner. I'm going to clip this over the leg of the both ends of the resistor. So that what I can do is I can come in with, say, please don't go bang, just get on there. I'll go get, say, I don't know, 470 ohm resistor and stick it in parallel with that 330. That'll jack the current back up to like 8 milliamps or something, and we'll see what happens to that voltage. Just give me 1 sec to grab a resistor. Alright, I didn't have to go anywhere. There was a 470 ohm resistor actually sitting on the desk right next to me, so you can't ask for more than that. Didn't like that. I think what the problem is here, I forgot to turn the bias down. Let me turn the bias down. That's interesting. So with no bias, we still have offset. Right, that's a bit better. Okay, so the more current, the more offset. See that? So it wasn't me decreasing the current source. Okay, that's interesting. I'm just going to quickly reset the bias. One moment. Because I have no bias right now. All right. Cool. That'll be fine. It might end up at 6 or something. So where's the offset come from? You know what? I just had another thought. I've got contamination all over this board and I spread it out with PCB cleaner. Maybe it's a contamination issue. Let's just again have a look at the offset. Hey, that's higher. What? What on earth? Okay, I'm a little bit confused. There should not be offset. Maybe it is just gunk on the board. Hold on. This could take a while because I've just got the transistors cold and now they've... yeah, it's having fun. I think I might have to go clean this board. I think that's what I'm going to do. I think that's the problem. I think it's just contamination because this thing's been really good with offset, even whilst it had oscillation. And I don't recall noticing the offset come back straight away after I got rid of the oscillation. I just noticed it at some point later on in the video. So I'm just going to go quickly clean this board up because the way that's unstable now, things aren't still icy cold. And I don't think that's gone into oscillation. I think I've just moved contaminations around the game. Hold on, let me just turn it off and turn it on. Yeah. I'm going to go clean the board. I think it's just contamination. I don't think there's anything to worry about. Let's hope so. Be back soon. Alright, I gave the circuit board a clean. It's not turned on at the moment. I'll turn it on now. That looks more familiar. Contaminants. This is why I'm always telling you guys when I'm working on stuff, you know, contaminants on the board. I always clean my boards up and make a big thing about it. Especially if you're working on high impedance circuitry or sensitive circuitry, whatever. Or the other thing that can come and get you, really give you a kick up the backside, is high voltage, because it can flash over in carbon track and arc and all that sort of stuff, you know. But certainly dirt, contaminants and stuff that don't belong on a circuit board will cause problems. Those numbers are just drifting around because I'm talking at the transistors. That's still not perfect, but I mean, to be honest with you, I can actually see still a whole load of contamination in between all the pins on the current mirrors and the input pairs. I haven't scrubbed the board down. All I did then was just sprayed PCB cleaner over it and then sprayed IPA over it to wash that off, and then just went over with some hot air to dry it up quickly. I haven't scrubbed it or anything like that yet, but I can see every time I start talking over here. Depends which transistor the air is falling on. Yeah, that seems alright. It seems like it's still got a couple of millivolts. I don't know, maybe it is creeping back up. Let's keep our eye on it. Don't forget, I don't have offset pots in here either. I'm not too worried if it's, you know, if it's around 10 millivolts or under that for now, whilst we're doing everything else, that's fine. I'm not going to sit here and install offset pots, because with all the other changes that I'm going to make to it, it's going to affect offset here and there only a little bit, you know, maybe a bit positive, a bit negative, but there's no point in installing offset pots now, doing a whole load of work to the circuit and having to constantly adjust the offset. It can just have a little bit of offset, and when it's built, I'll put the offset pot in and trim it to absolute 0 microvolts, you know. But that's definitely lower than what it was. And every time I move away and stop talking from on top of it, it seems to drop a little bit. Let me clip onto actual ground. Alright. I'm just going to short the input too. Just want to see with that capacitor, input capacitor, like going to ground off the input. So there's essentially a small reservoir on the basis of both the inputs. I just want to see where it wants to sit there. Yeah, around the same. Alright. So we know it's basically, it seems to be resistor mismatching or transistor matching in this current mirror, I think. I don't think it's anything else. And like I said, I'm not going to worry about that now. Alright, so let's go back to putting a signal into it. Well, you guys can see that. We'll go back to putting a signal into it. Get it to do that thing where it starts to clip funny on the negative portion. And I will add the Baker clamp diode and remove the Baker clamp diode, and we'll see if it has any effect. And the other thing I wanted to have a look at is the sub rail, because I've got a funny feeling that that's going, like, bringing, maybe even, like I said earlier, this whole rail. So basically giving the input stage like a longer tail and a lower, a sub rail voltage for the fast and beta enhanced transistor. I'm just going to clip on where my Baker clamp would go. Alright, that's ready. That's ready. Get the scope over here. Still ground off the Zobel. Good enough. I'm just going to bring my signal over here. I'm just going to clip ground onto some other random spot. Doesn't have to be audio ground for this test. This is not crucial. That's not going to affect it clipping the way it is. Sorry, my signal generator is not turned on. 1 second. I'll set this to AC. I'm just going to turn the amplitude down on this because it was all the way up there. If I turn it on. Alright, signal generator's on. I'm going to start winding up my signal. Oh, shit, no, something's wrong with the amplifier. Hold up. I am drawing, hold on, no, that's not right. This amplifier is drawing way too much current from the power supply, hold on. When I say too much current, it only went up to 400 milliamps, but that's not right. Something's happened. Hold on. It's only just come down to 100 milliamps now. And it should be like 70 really. Let's have a look what the bias is at. Bit high. I'll just leave it there for now. Okay, so it's not that bad. Let me just unplug this lead off of the sensitive base. Well, I'm drawing 56 milliamps now. Much more respectable current. I'll set this back up. I'll ground this properly this time. I don't know what happened there. Maybe it was just me setting up a bit dodgy. Trying to take shortcuts. Alright, so we've got nothing on the output. Okay, my current draw hasn't gone up this time on the power supply. That's interesting. So I've got to ground it in the right spot. That's okay. Let me just stick this lead on the base of the beta enhanced transistor and make sure that's not what was actually causing it. No, still 56 milliamps. Okay. Lesson learned. Audio ground must be audio ground. Alright. Turning up the function generator. You know what I haven't done? I haven't connected the scope. It might help. Might really help. Alright, now again I'm turning up the signal. Alright, I'm at the part where it starts to go funny. That's drawing about half an amp. I don't like that. Hold on, let me turn that down. Yeah. I don't know, that could just be the Zobel and the base resistors, I'm trying to say, not the base resistors, the resistors that go between the bases on each side, between each stage, because that's going to dissipate power as you turn it up. I think it's just that. Anyway, let's just do what we're doing. Well, shouldn't have done that. Alright, so you guys can see what's going on. We're back to this. Alright. What I'm going to do now is I'm going to turn off the signal generator, off the supplies. I'm going to add the Baker clamp diode, pointing towards the collector of the fast transistor from the base of the beta enhanced transistor. That's just sitting there. Alright, I'm going to turn the amp back on. It appears that we've lost bias. Looking at my power supply, it appears that, well, no, there's still bias, it's just a little bit lower. Anyway, it's probably because I've just stolen drive from there. I'm going to turn the signal, let me just turn it down first before I turn it on. Alright, I'm going to turn it back on. Start turning it up. Oh, God, no. No, that's hilarious. Do you guys want to see? I'll show you. With the Baker clamp in there, this happens. And we're only at like 22 volts. So that's not going to work out. I'm just going to turn this down, turn it off, turn my supplies off, and remove this Baker clamp diode. We could, for shits and gigs, just to see. We should do this actually. Not that I would ever put like a normal diode, like a 1N4148 in there, but I'm just going to grab one, just so that we can see with a bigger forward voltage drop instead of the 1N5711. Let's see what it looks like when we turn it up with a 1N4148 in there. Purely just for the fun of it, really. Alright, I'll turn the supplies on. Amp's up and running. Turn the signal on. Got signal. Come over here. Take the focus lock off, and I'll start turning my thing up. So we're definitely going higher this time. Much higher. Hey, look at that. Symmetrical clipping. Ah, that's so annoying. Oh, God. Alright, so I'm definitely not just going to whack a diode across that. And yeah, I have thought about all the alternatives. I could take, say, 2 Bass 21Ss, or K or whatever it is, and put them in series to make a higher forward voltage drop, and that would probably work nicely, maybe 2 or 3 of them. And it wouldn't be as small a capacitance as this, but it would still be small. I mean, I said that the wrong way. Wrong way around. It would be a smaller capacitance than like a 5711 or a 4148. Sorry, I've just lost my diode. No, I haven't. I was screwing it up in my hand. I do stupid things sometimes. I was looking at these end of the clips thinking I've lost the diode. Anyway, there are other ways around this, like mounting another transistor off the VAS that, I forget what you call it, a tracking transistor that makes sure that basically both sides are clipping equally. Could do that. I'm interested to see, because like I said, I wanted to add, a couple of current sinks and a current source, and that's just overkill. If I could just add a current source to the beta enhanced transistor and make this whole rail regulated, that solves all those things with only 2 regulation circuits. Now, I want to see what happens if I run the rail. We'll experiment with a few different things. We'll try just the VAS transistor, both the VAS transistors and the whole rail off of a lower, when I say lower rail voltage, I mean I'm adding an extra 3 volts on negative to the negative rail. So I don't mean I'm turning it down, I'm turning it up, but it's negative. You know what I'm trying to say. Let's see how that evens out the clipping that we get. I did also notice that the diode took care of that sort of overshoot. It looks like it's about to break into some sort of triangular oscillation, and it just does like one did it and stops. If you remember, on the wave it would come down, it would go flat, and I'm talking about that. So I'll be curious to see what playing around with the 2 transistors or the rail itself has, how it has an effect on that. So that's what I'm going to do now. That's what we're going to look at right now. So I'm going to bring the sub rail back over here and we'll play around with that. Because if that works out, I would way rather do that. It's better than adding a band-aid like a Baker clamp that degrades sound quality. It's also, like I said, better than adding 2 sinks and a source, because I only have to add 1 regulator for the rail and 1 source for the beta enhanced transistor. So it's better for 2 reasons. Let me go get a sub rail set back up and we'll have a look at this. But I was just having a look through my surface mount diode collection. I've actually got quite a few different types of surface mount diodes, and there's the BAS21J. Turns out it's not a Schottky, so I wouldn't actually have to use multiples. That's interesting. I still don't like the idea of putting one there, although, from research, if I was going to, I'd add a small bit of resistance to it and use a BAS21J and it would work nicely. So, food for thought. If we don't accomplish what we want to accomplish by changing the rail voltage, at least the BAS21J is still an option. I was thinking it was a Schottky a minute ago when I was just saying, it could double them up, this sort of thing, because I really don't like that idea, but it's not. So that's cool. Alright, so it's much later in the day and I'm back in here on this now. So, I'm not sure if I had mentioned in the video before, I can't remember, I haven't watched my last clip, I can't remember what I was saying, but we're going to try a sub rail again and see basically how it affects this clipping behavior. So, just got to see what everything's hooked up to, where I'm at. We should be set up. Let's turn this on and make sure everything's good. No, everything's not good at all. Okay, something's terribly wrong. Tried to turn my power supply on and it was drinking a lot of current. What could be happening? Maybe it's something to do with this input. Yeah. Okay. There was some DC built up there or something. Probably would have settled out. I don't know. Maybe it wouldn't have. Probably wouldn't have actually. Anyway, so that appears good. All right, so we're where we were. Okay, great. I'm going to turn my signal down and scope back on. All right, so what I'm going to do now is I'm going to lift the resistor that goes to the emitter of the VAS transistor. Might as well turn my soldering iron on, turn the power supplies off before I attempt to do that. I'm going to lift that, run it off of a slightly lower rail. Now, how much lower? Okay, I'm going to start 1 volt lower. We're just going to see what that does. I just want to point out quickly, if anyone's been looking at the wave, I know it looks fairly clean, but it looks slightly messy sometimes, like there's a bit of noise on it. This is on 10x. The gain on my scope's turned right up, so that's all that is. The amp's not misbehaving or anything. Alright, with that being said, I'm now going to set this up. Need some water for my sponge. Alright, I'm going to try and power it up again. I know I've still got that input connected. I've got the 1 volt rail attached, the extra minus 1 volt, so let's see if it even starts up. Yeah. No. Okay. Okay, that 1 volt is really upsetting the apple cart. There's an old one. Alright, I'm going to put a short over the 1 volt so that the 1 volt's not there, just to start up. And then I will remove the short. Oh, that's not good. Okay, we've actually got a problem. Something's up. I can't power up. Now, I know this was a bit funny about it before, but I thought it was just because of the extra lead inductance. This is odd. I'm just going to click this resistor down to the negative rail. Okay, so it is that. Alright, back to the sub rail. Just keep trying. Nah. That ain't working. Jeez. I'll take the short off. Put the volt back there. See if I can get to start up with the volt. No. Okay. What if I turn the volt all the way down, but I leave the power supply's output on so that it can still pass current? Let's try that. Ha! I knew I'd figure it out. Oh no, we're drinking an amp of current. Oh god. Don't worry, I'll get there. Maybe I'm doing it the wrong way. Let me set a really small voltage, like 10 millivolts, as the extra. There you go. No, we're burning an amp of current. Okay, this is not working for me, which is weird because I swear I could get it to work before. That wouldn't have thrown the bias out, would it? I'm going to turn the bias all the way down. I don't see how it could be that, but whatever. No. Wait, you've got to be shitting me. Oh, that threw the bias out. I'm not drawing excessive current now. Okay. Let me start incrementing this sub rail. So that's 1 volt. Alright, I'm going to step it up in 10 millivolt steps. I'm already up to 0.64 of a volt. Oh, okay. Right. So as soon as we get to that transistor junction threshold voltage of about 0.6 of a volt, it seems we can't go below that. Let me just see what happens if I keep turning it up in small bits. Because I'm at 0.62 of a volt now. It's definitely hurting the response. No, that's not right. Okay, I'm going to turn that back down. Alright, so that doesn't work. Well, okay. What I'll try then is I'll try both these emitter resistors running from a sub rail. Alright, I just had a bit of a mishap. Problem solved. What I did was I forgot to turn the amplifier off. Tapped the soldering iron on that solder ball there. Negative rail. Blew open the 22 ohm rail resistor. Replaced it. Amp's all good. So, I've got both of these emitters floating off the rail now. Going back to the shared lead. To the sub rail, which is currently set again for 10 millivolts. So I'm just going to power up the amp and see if I can get it to stably power up like this. Alright, that's good. And when I say stably, I mean bearing in mind all of these extra long bits of wire with inductance. You can think of it as trace inductance. I'm going to start turning up the voltage on the sub rail. I'm going to do it in 100 millivolt steps. Yeah, I'm up to 6, 7, no. Yeah. Okay, so no bueno. I'm back down to 10 millivolts. I'm going to turn off the supplies. Very important to do that. Alright, what I'm going to do is I'm going to put these resistors back down and I'm going to power this entire sub rail. So the input stage is tail end and those 2 emitter resistors on the VAS transistors from the sub rail. Let's see what that does. Alright. So I'll just move that so I don't heat the plastic up and melt it. What I'll do is I'll lift this end of the 47 ohm resistor, the 22 ohm resistor, the end that the power comes in from, so we still get our RC filter there. And I'm just going to get rid of one of these extra wires. I'm going to hook the sub rail on here. So now the entire negative rail is on a sub rail. I just wanted to say the reason why I would rather do a sub rail and the current source instead of two current sinks and a current source. It's not just the fact that there's less regulation circuitry. It's not hard for me to make a sub rail. There's two ways of going about it, obviously. I don't know if that's obvious or not, but I mean, there's probably more than two ways of going about it, but I can straight off the bat think of two ways of doing it. One not so good, the other very good. One way, the less good way of doing it, you could build, you know, some sort of boost circuit or like a charge pump circuit or something like that to produce an extra voltage off of its actual rail. But the way I would do it is I would wind an overwinding onto the minus whatever fault winding on the transformer and rectify and smooth that and bring that in. And for me to do that, that'd be very, very, very easy. You know, I've got plenty of copper wire. I just put some fish paper or something around the core, wrap, get a few volts. That's it, you know. Not even a few volts, but yeah. So it would be really easy to do this. Although I'm going to want it to be a regulated sub rail. So actually, yeah, I would want quite a few volts because after regulation, it's only going to leave a few volts. So you know what I'm saying anyway. All right, so what I'm going to do now is I'm going to power this back up and we'll see what happens. See if we can even start it up like this. I've only got a 10 millivolt offset on that negative rail at the moment. Okay, no. Might help if I plug the multimeter in. We can see what's happening. Alright, I'll try again. Alright, we're up and running. Okay, I'm going to now, I'll wait for that to stabilise. That's close enough. Right, I'm going to start turning up the sub rail. Now I can turn it up. Now I've got everything running off the same rail. I'm already at 1 volt. So that seems to be the secret there. Let's put a signal through it now, because I've already got the entire rail 1 volt lower than what it was. So I'm going to put a signal in it now and we'll see what comes out. So I'm just trying to get my amplitude set. Alright, so I'll bring you guys over to the scope. I swear this amplifier is not biased. Hold on a sec. Must have some little bit of bias. Maybe the negative feedback's taking care of it. Anyway, Sorry, every time that waveform jumps, I can hear something over here going zit, 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 zit. And I'm sure that noise is coming out of my power supply anyway. Alright, so as we saw there, we do start clipping at the positive first, but then all of a sudden that thing happens at the bottom. That's alright, let's turn that down. Power supplies are still good. Kitty's still sleeping. Alright, I'm going to turn this, we'll give it another volt. So nothing crazy's happened. Amp's still running. Turn our signal back up. So that whole rail is now 2 volts lower than what it was. That's interesting. It's going to turn it down a bit. Going to go up to 3 volts. Alright, 4 volts. I've gone up to 4 volts of offset. That does seem to be starting to have an effect. Hold on, let me just turn that up to 5 volts. 6 volts. Yeah, well, it is starting to clip on the positive going side first now. So that's interesting. And if I don't turn it up too much, I can get it to reliably sit there and clip on the positive half before the negative half. So I could actually dial this offset voltage in. Yeah, I'll go back to 5, 4, 3, 2, 1. Oh. 4, 3, 2, 1, 2, 3. So it seems, that's funny. I read, oh no, it's, sorry, 4 volts. I read someone on a forum say about 3 volts. But anyway, I'm just going to go back to 3 for a sec. 2, 1, 2, 3. No, 3 volts actually does do it. That's funny. Alright, turning the signal down and back up. Yeah, 3 volts does actually make it clip on the positive half before the negative half. However, it doesn't stop the VAS transistor from going into saturation and that small little blip at the same time as it goes into saturation. So I'm going to have to dig deeper into this. That's okay. It's all good. I'm just going to wind this signal back down. I was going to turn everything off for now. I don't need this on right now anyway. Actually, what I'll do before I turn it off, I just want to have a quick look at the bias. Just curious because there was no cross distortion. Yeah, there was just a smidgen of bias there already. So there you go. Alright. I might end this video here. I think we've already covered quite a bit. We can clearly see what's going on. We can see adding a Baker clamp makes it symmetrically clip. We can see bringing this whole rail down lower has a similar effect but not as good of an effect. So I'm going to go off and do some thinking, possibly some research, and see what I can come up with next to improve this. Yeah. Also, I'm still trying to work out if it's the Bass 16 or the Bass 21. Someone in the comments section is trying to help me out. Thank you. I don't know how to pronounce a channel name. I think it's Ivo Lol, something like that. Thanks for your help. I'm going to download that Nexperia data sheet and have a look at that now and see if I can work out which diode actually does have the smaller reverse transfer capacitance, and if I have to use a clamp, I'll put some resistance in series with it and use that particular diode that I choose. But yeah, alright, well, I'm going to end the video here because, like I said, I'm going to go off, do some thinking, come up with a few ideas to try, and that'll be the next video. So thanks for watching. If you like the content, please give me a like and a subscribe. I'm trying to grow the channel. And to everyone that's been with me so far, and to all the newcomers, I guess, as well, thank you. And I'll see you all soon. Take care.